So today we're going to learn about solving systems of linear equations and through the graphing method. So we're going to graph two lines and we're going to see where they intersect. That is the systems of linear equations. So if we have two lines here, we've got a red line, which is an equation, and we've got a green line. Where do they intersect? So the solution to this would be this point of intersection, and that would be 1, 2, 3, 1, 2, 3, 4, 5. So that point of intersection would be 3, 5. That would be the solution. Typically, however, in this example, we will be giving two equations. So both equations are in slope-intercept form. So we are going to graph each of them and then see where the intersection is. So the slope of this line is -3/2. The y-intercept is 3. So let's graph this. We're going to graph the y-intercept first. So we go up on the y-axis to where it's +3. 1, 2, 3. And then we use the slope, which is -3 over 2. That means down 3, right 2. So we'll go down 1, 2, 3 to the right 2. We'll make another point, down 1, 2, 3, right 2. And we'll connect those lines, and we will color it green. And we have all of the solutions to this equation. The equation y equals -3/2 x plus 3. These are all the solutions. Now, is there a common solution with the other equation? So the other equation's its slope is 1/4 and the y-intercept is -4. So let's graph that. Y-intercept is -4. We go on the y-axis to where -4 is. That's down 1, 2, 3, 4. And then we use the slope, which is up 1, right 4. Up 1, right 4. We're going to connect those lines. Make it a little bit larger, and we're going to make it red. Connect those dots, and we see where is that intersection. This is a relatively easy intersection because our slope took us to the point. It took us to the point of intersection. So if we look at that point of intersection, trying to get that, thank you, that would be 1, 2, 3, 4 on the x, and 1, 2, 3, -3 on the y. So the point of intersection, or the solution, and the answer is going to be 4, -3. That means if we plugged it into this equation, we get the left side equal to the right side. And if we plug it into that equation, we would also get the left side equals the right side. So if we look at points, let's talk about this. If we have this point right here, that is true for the green, but it's false for the red because it's not on the red line. It's on the green line, so it's true for green, false for red. What about this point? Well, this point is going to be false for the green line, but true for the red line because it's on the red line. What about this point? What's that point going to be? Is that going to be true, 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 false, false, true, or false, false? Yeah, it's going to be false, false. And it's false, false. It's false for the green and false for the red because it doesn't lie on either of the lines. And then if we go here, we get a true, true. Down with the true, true. So it's true for green and it's true for red. So we're always looking for the true, true. True for red and true for green. Okay? So that's what the solution to a systems of equation is. Try this one. I'll give you a couple seconds. We'll pause. You should pause the video. I want you to graph both of these equations and then tell me where the point of intersection is, the solution to the system. When you're ready, push play. So the first thing we need to do is we need to find out what is the slope? Well, the slope of this line is -7, and the y-intercept is 3. Let's graph that. Up 1, 2, 3. Slope of -7. Remember, -7 as a fraction is -7/1, so we're going to go down 7. 1, 2, 3, 4, 5, 6, 7. Right 1. Down 1, 2, 3, 4, 5, 6, 7. Right 1. And we'll connect those dots. And these are all the solutions. It's a little bit off. That's much better. And now let's do the x, y equals -x. So that slope is -1. The y-intercept is -3. So down 1, 2, 3. And then my slope is -1, which is -1/1. So I go down 1, right 1, down 1, right 1. Let's make our line. And if we connect them perfectly, we notice that they have an intersection right here, which would be 1, 1, 2, 3, 4, -4. So that would be the solution to the system. Now, how else can lines intersect? Well, we see here when you graph the equations in the same coordinate plane, you see that the lines have the same slope but different y-intercepts. The graphs are considered parallel lines. Remember, if they have the same slope but different y-intercepts, they won't intersect. If they have the same slope, they are considered parallel. Since the lines do not intersect, there is no point that represents a solution to both equations, so the system has no solution. That would be the answer to this problem, no solution. How many points intersect in the problem before? How many points? 1 point. And we want to know the location. Where does it intersect? So don't tell me 1 point, tell me the specific point of intersection. With these, when they're parallel, there is no intersection. So there is no point that intersects, so the answer is no solution. Take a moment, look at these two equations. I want you to graph them and then tell me what the solution is. When you're ready, push play. So the slope of this is going to be 1/2. The y-intercept is going to be -2, down 2, make a point, use the slope, which is up 1, right 2, up 1, right 2. Connect the lines. That's not good, it's red. I don't need it to be red, I need it to be green. There we go. And then our other line has a slope of 1/2 and a y-intercept of -1. So negative, come on. Oh gosh, not infinite. You have -1, and then you have a slope of 1/2. Up 1, right 2, up 1, right 2, up 1, right 2. So if we take that and let's change that red, we notice that those two lines are parallel and they will not intersect because they have the same slope. Lines that have the same slope will never intersect. They are considered parallel if they have different y-intercepts. So the answer to this problem is going to be no solution because they don't have a point that they share. And then the last one is when you graph the equations in the same coordinate plane, you see that the graphs coincide. What does coincide? It means that they lie on top of each other. They are the same line. The equations are equivalent. Every point on the line represents a solution of both equations. So you're going to get some interesting answers. The system has infinitely many solutions. You're going to see that as an answer in a lot of books. You're going to see this, all points on the line are going to be the answers that you see from me. But you may see infinite. You may see infinitely many solutions. I don't want to know the number of solutions. I want to know where are the solutions. So since these are identical lines lying on top of each other, all of the points on the line are the intersecting points. That's where they intersect. So let's try this. And notice this, there's two things that go on in this one. Notice that this is not in slope-intercept form. So the first thing you need to do is get these equations in slope-intercept form so you can graph them. Right at the moment, you can't pull out the slope and the y-intercept because it is not solved for y. So take your time, isolate the variable for y for each of these equations, find the slope, and then plot the equation. Pause the video when you're ready and you finish this problem. You can hit play. So the first equation is 6x minus y equals -3. We have to isolate for y, so I'm going to subtract 2x. Remember, I'm putting it in slope-intercept form. That's isolating the equation for y and getting the variable y by itself, and then you'll have x come first. So the coefficient is -1, so I'm going to divide by -1, and I get y equals 6x plus 3. So if I graph that, y-intercept is 3, slope is 6, which is up 6, right 1, 1, 2, 3, 4, 5, 6, right 1, or down 1, 2, 3, 4, 5, 6, left 1. Let's make a line. Let's change that color again. Let's do that. Good. Color is green to go with its dots. Now let's take my other equation. You have -6x plus y equals 3. -6x plus y equals 3. We're going to isolate for y, so we're going to add 6x to both sides. We get y equals 6x plus 3. So my y-intercept is 3. I go up 3. My slope is 6, so I go up 6, right 1, or down 6, left 1. And what do we notice? It's right on top of each other. They coincide. So, oh, that one, okay, there we go. There's that line. Kind of wanted it to be red, not. But we see that the lines lie on top of each other because if we look at the equations, you have y equals 6x plus 3, and you have y equals 6x plus 3. They're the same equation. When they're the same equation, we know that the solution is going to be all points on the line. That's my solution. Cool. So you can have 3 different types. You can have where they are the same line, where they are parallel and don't intersect, and where there is one solution. So to solve, if the lines intersect, there is only one solution, namely the intersection point. If the lines are parallel, there is no solution. And if the lines coincide, there are infinitely many solutions. And we have to remember that when it's given to us in standard form, this is standard, we have to put it in slope-intercept form. We want to be able to pull the slope and the y-intercept. Sound good? All right, good luck.